Okay, welcome back. This is DSP 2021-2022 in SEM 2. We are now on week 4, Friday, the 4th of February. So in terms of the lectures, we are in lecture 8 recording now for Zoom. Lecture 7 was during Chinese New Year. So for today's recording, I'm going to do again Q&A. I'll do Q&A for one exam questions first. The questions will be from 2018 November, December, question 1. The coverage for this question is this. Mainly it is on Z transform, pole and zero diagram stability type of filter, direct form realization, and impulse response generation. So you, in fact, to answer this question, it takes all the knowledge of this material. I'm going to show you now which material I'm talking about. It is on O4AZ transform. Okay, guys, you're looking at my screen, right? Can someone answer? Yes.
Yes.
All right. So go to O4AZ transform. Now to answer that question, you actually just need to, if you understand, you just need this figure, page 65. This figure will be used to answer the entire question. So this figure requires all the knowledge. This figure shows all the knowledge that is required in the question. I'm going to show you the question now, and then I'll show you how to answer the questions using this figure as a guide. All right, so I'll write the questions now. Now, before I start with the questions, first is sometimes I'll use MATLAB. MATLAB is not going to be examined in the examination. MATLAB to me is just a calculator or some kind of software to check your answers. That's all. Okay, it is not examinable. So for example, if I give you a fraction or I ask you to find a root of a polynomial, I will use MATLAB to find it for me. I'm not going to do it by hand. But you guys, of course, have to do it by hand. The absolute value of a complex number, the angle of a complex number. MATLAB can do it for me, but you have to calculate by yourself if you have only a calculator. Your calculator, the one you calculated, you should get is the one that is approved by NTU, and that should be able to do complex numbers easily. Okay, some calculators can do complex number in polar and rectangle form. You should get a calculator that can do that. All right. Then you say why I'm using MATLAB and I'm asking you to use Python. Actually, whether you use MATLAB or Python, it is the same. This is just like saying, do I use C++ or C or Python or Java? So to me, MATLAB and Python are doing the same thing. Okay, so it doesn't matter which programming language you use to check your answers. That's all. I mean, you can do the whole lab in MATLAB if you so choose. Yeah, it doesn't matter because they are nothing but procedural language. All right, let's come back to this question and let me try to answer it in about 25 minutes. So that's all you have for the exams anyway, about 25 minutes for each question. Okay, let's see the question now. So it's 2018, November, December, question 1. And the question, there is a mistake first. So the difference equation is given to us. And the difference equation is y of n is equals to x of n plus 2x of n minus 1 plus 0.1 y n of minus 1. So if you check out the exam papers, the exam paper says 0.1 y of n, which is wrong. The correct question is 0.1 y bracket n minus 1. So the difference equations basically says I have a system that takes an input here, and this input is x of n, and I'll get a y of n. And this y of n follows this equation. All right. So the first question asks, sketch the DF1 representation. DF1 representation means the direct form 1 representation. So what is this little box here? Okay, so this little box here is exactly the equation over here. So let us now try to draw the little box. So the first is, of course, x of n is on the left-hand side, y of n is on the right-hand side. So if you see the equation, y of n is equals to x of n. So this is, you can say, hey, y of n equals to x of n. That's what I get out, right? What about plus 2 xn minus 1? So what does it do? Well, it basically goes through a delay. This is a delay block. And what we'll have here is x of n minus 1. All right, so we need to multiply by 2, right? You look at the above, we need to multiply by 2. And so we use a triangle block to say this is a multiplier by 2, and then we need to sum. So now we have plus 2 x of n minus 1. All right, so sometimes you are very pedantic. You say, I need a multiplier here, and this multiplier here is 1. So it's 1 times xn plus 2 times xn minus 1. All right, what about the last guy? 0.1 yn minus 1 plus 0.1 yn minus 1. Where do I get yn minus 1? From the output, yn. I punch into a delay block. So here is y of n minus 1. And I have to punch it through a multiplier of 0.1 and then sum. So that's it. So you have a 4 marks here. All right. So a 4-mark question within 3 minutes, you can get it done. Okay, so that's the first one. Right, any questions, guys? I'll pause. Right, so this page, right, is a guide. So I've given you a difference equation, and I ask you to draw the direct form 1. In my part, you only learn the direct form 1. Later on, in the second part of the course, you can do like direct form 2, transpose form, different form. But the direct form 1 representation is the simplest. Okay. All right. So that's the 4-mark question here. Okay, now B. The second part of the question says, find HZ, the transfer function. The transfer function. Where is the transfer function from? The transfer function is actually the Z transform of the impulse response. So this is the impulse response. That's one way to get it. Or you can actually, well, let's find the Z transform first. All right, so the Z transform can be done by this method or directly the Z transform from the difference equation. So we are going to use this method, okay? So to get the difference equation, what is the difference equation? Well, let's see the difference equation first. So if I do Z transform of Y of N, I will get Y of Z. Z transform of X of N, you get X of Z. So this is very simple. It's just a changing a notation. What about Z transform of, what do you call that? 2x of n minus 1. So this is a bit special. So the Z transform is, you can bring the 2 out, then Z transform x of n minus 1. What is n minus 1? So 2 is Z minus 1 due to this minus 1 here, x of Z. Okay. So this is what you need to do. All right, and the last one, of course, is the Z transform of 0.1 y of n minus 1. So you follow the style above is 0.1 z minus 1 y of z. So with this the properties of the Z transform, I look at the equation, which is originally y of n is equals to x of n plus 2x of n minus 1 plus 0.1 of yn minus 1. What do? I perform Z transform. I use this table, and then this is y of z. This is x of z plus 2z minus 1 x of z plus 0.1 z minus 1 y of z. So there's only trick that you do, and then you collect all the terms together. Y of z, 1 minus 0.1 z minus 1 x of z, 1 plus 2z minus 1. And then now, therefore, h of z. What is h of z? Is y of z over x of z. H of z is called the transfer function. What does it do? Why is it called the transfer function? It is because it transforms the input x of z multiplied by h of z equals to y of z. So it transforms the input to the output. It also means the output over the input is a transfer function. So therefore, it is equals to 1 plus 2z minus 1 over 1 minus 0.1 z minus 1. So this is the h of z. Typically, we don't like to write it in the negative power of z. So we multiply the top by z and the bottom by z to get rid of the z minus 1. And we get z plus 2, z minus 0.1. So this is the answer. All right, so this is part of the answer, which says find the transfer function. Then after that, the second part of the question says sketch. Sketch what? The pole and zero of h of z. All right, so we have this little guy here, which is h of z. What are we sketching? What is z? So remember, z is the complex number. So first we draw the complex plane. So this is the real part of z, and this is the imaginary part of z. And then typically we draw the unit circle first. So this is 1, this is 2, this is the origin. This of course is minus 1, and this is minus 2, and this is j, and on top is 2j, and below is minus j and minus 2j. We then draw the unit circle. The unit circle is the circle that have unit length, and then, so we show you where the unit circle is. And then we take the function here, and we're interested in this guy, and then this guy, z plus 2. So when z is equals to minus 2, then minus 2 plus 2 is equals to 0 on top. The whole thing becomes 0. So z at minus 2, which is this point here, is a very special one because this is called the 0 of hz. Okay, what about the pole? When z is equals to 0.1, 0.1 minus 0.1 becomes 0. So the whole thing divided by 0 becomes infinity. Where's the 0? This guy here. So here is the pole at 0.1. So we have a 0 at minus 2, a pole at 0.1. Then now the question asks, determine the stability. Now, because the system is causal, what you do is you draw a circle here with radius 0.1 here, and now you're going to draw the, what do you call that? The region of convergence. The region of convergence is external. The ROC is external to the furthest pole of the system, and the furthest pole, there's only one, so you draw a unit circle, not a circle, you draw a circle of radius 0.1 here, and you draw this hairy line to say that all this part, any of the values z, will make the system converge. Now this system, this ROC includes the unit circle, so you see, so ROC includes the unit circle, and therefore system is stable. Okay, so there are a lot of things going on here first. So the answer is stable as ROC include unit circle. All right, so this part and this part is about 6 marks. This part and this part is about 6 marks. Okay, now the last part, the 2 marks, asks what kind of filter is this? And the answer of this is it is a high pass filter. High pass filter. Some of you will tell me it's a band pass, but it's okay. So I will show you what is a high pass and low pass filter now. The reason why it's a high pass, it's a, I take it back. It is a, sorry, it's my mistake here. Oops, it is a, the correct answer is a low pass filter. low. And the reason why it's a low pass filter is we can sketch this. This is omega, the frequency, and the low frequency will pass and the high frequency will fail. So this is the magnitude of the system, magnitude response. And the magnitude of the response is interested in the low frequency. So this is the low frequency and towards the high frequency. And then the low frequency has gain of, for example, 1, and a high frequency, the gain is 0. Okay, how can you recognize this? You have to go to the lecture to realize that pole locations, frequencies nearer to the pole will have high gain. Frequencies nearer to the 0 will have low gain. The frequency goes from here at 0 pi, pi over 2 to pi. So we're interested in this part of the curve here. Okay, so all this you must know from the lectures. So I will pause now. Okay, let's resume now. And we are still in question 1C. And then it says evaluate h of n. What is h of n? H of n is the impulse response. How to get the impulse response? You send x of n to be the delta of n. That means this is what you send. 0, you get send 1, and everything else is 0. So he's asking you, send this signal into the system and then get y of n. Y of n, whatever is y of n, is the impulse response. Why does it say it this way? Because I send an impulse into the system. This system is the LTI. It must be LTI, of course. Then whatever you get is the impulse response. So how do I, and then it says evaluate. Okay, so I'm going to use this idea of sending the impulse. And what do I do? So the simplest one I can do is brute force, okay? N at -1, what is my x of n? What is my x of n minus 1? What is my y of n? And what is my y of n minus 1? Okay, now let us start with a relaxed system. A relaxed system means all the memory is 0. The output is 0. So we say that the system is relaxed. Can? So this first line is to tell you that the system is relaxed only. So if I never tell you, you can assume, or you should assume, you must assume that the system is relaxed. At time equals to -1, x minus 1 is 0, xn minus 1 is 0. Everybody is 0. The input is 0, the output is 0. At time 0, what happened? I fire the impulse. So at time 0, I send a 1 here. So see, I send a 1 here. So what about xn? What happened to xn? You go and look at the figure here. Xn, once I fire a 1 here, this xn will move into here, right? So xn will move to xn minus 1. Yn will move to yn minus 1. So if you really want to see, this is what happened. This 0 move to here. Okay, what about yn? Yn move to this guy. So I have xn, I have xn minus 1, I have yn minus 1. I can use my equation, right? Remember what is my equation? My equation is y of n is equals to, let me see my equation again, x of n plus 2x of n minus 1 plus 0.1 yn minus 1. See, by brute force, right? I can see my equation, I can see all my value, and the answer is, of course, this is 1 plus 2 times 0 plus 0.1 times 0. The answer is 1. Okay, so I don't need to do the working. I can throw in my working, and I just write 1 here. Okay, now what about time 1? Well, my impulse goes from my input to this guy. And what about the new xn? Well, the new xn is here, so it's 0. Okay, my 1 moves to here. So now I can compute this guy here. So what's this value here again? Since I have xn minus 1, yn minus 1, I plug into this equation and I will get, the answer is 2.1. Okay, everybody can see 2.1? Xn is 0, but 2 times 1 is 2, plus 0.1 times 1 is what? 0.1. So 2 plus 0.1 is 2.1. So and what about this one? So it's very boring, okay, guys? And then, so this is 2.1. And then now what? So now is the clever part. Everything else is 0 now. So the top guy, xn and 2xn is nothing now. So it's 0.1 times yn minus 1. So it's 2.1 becomes 0.21. So now you can see the pattern. Okay, guys? 0, 0. This guy goes to 0.21. And then finally, this is 0.021. And then, in fact, the fourth one is even easier. 0, 0. This guy, 0.021. Oh, this is 0.0021. Can you see the pattern now? So once you can see the pattern, therefore you can express Hn equals to some equation. All right, but of course, before we do that, we want to answer the question so that we can get our marks. So we look at this column. This is our output. So we get 0, 1, 2.1, 0.21, 0.021, 0.0021, and so on. And then we put an arrow here to say that this is n equals to 0. So this is our Hn. How many marks is this question? This question is 6 marks. So 6 marks, you have to get this right, as well as the closed form solution. Now, how to get the closed form solution? Can you see the pattern? Well, if you can see the pattern, then the closed form solution is this. Is equals to, so it's not so easy, but you can see this. Okay, so why is the closed form solution like this? Let us see. What is this? This is 20 times the impulse. What about this guy? Un. This means n equals to 0, 1, 2, value un equals to 1. So this one tells us that the signal exists from the right-hand side from 0. N equals to 0, 0.1 to the power of 0 is 1. 21 minus 20 is 1. Okay, so we get the first one right. Over the second one, you substitute in, you get 2.1. Substitute in again, 0.21, 0.021, so on and so forth. Okay, so this one, it takes a little bit of a trick, mathematical trick. I won't show you how you can learn. Okay, I'll pause now and we'll see. All right, the student asks, why do I draw this arrow down? To understand why I draw the arrow down, let us understand this is n for different time index. This is value of xn, value of xn minus 1, yn minus 1. Where do I get all this value from? The first value is all zeros, because I'm showing you that when there is no input, there is no output. And the system memory is 0. Now, at time, from time minus 1 to time 1, what happened? Why do I draw 0 go from here to here? Let us call this value 0a. Why is this 0a? Okay, where is 0a? So let us have at time 0a here. Originally, this is 0a. Where's 0b? Let's call this 0b. If there's 0a, this guy is 0b. Can you see? If this 0a belongs to xn, 0b belongs to xn minus 1. Let's call this 0c. Can? Where's 0c? Let's see the figure again. 0c. Can you see now? 0a here, 0b here, 0c here. When I send into the system, I will get my value 0, right? Because 0 times 0.1 is 0, 0b times 2 is 0, 0a times 1 is 0, everything ends up is 0. Can? So this is at time n equals to minus 1. What happened when now I go from time n equals to minus 1 to n equals to 0? It means that I'm going to push 0a into here, right? Because I'm going to push new data into the system from outside. When I push outside, 0a must flow into here, right? It is like a, what do you call that? Buffer. 0a will go to here. Where do 0b go to? 0b is gone. So now At time 0, what do I push? I push an impulse. So I push 1, A here. What about this guy? This guy is 0, A. Agree? The output is originally from here, 0D will be pushed into 0D here. Can you see now? Yes or no? I push the new data into my system. As I push into here, my data will flow down, right? My xn minus 1. When n is 1, sorry, when n is 0, this becomes x minus 1. Agree?
Yeah.
Yeah. So you are pushing the data. All right. And then, so I'm drawing that little arrow here to show you all the data. 0a from xn will flow to xn minus 1. The new data 1 comes in. When I push again, the new time index 1 will flow in here. Can you see now?
Prof, everything is like all constant one, consistent one. Like if you give any other equations, then it's all also like that, is it?
It depends on this equation, friend. So of course, it depends on whether, I mean, I'm doing xn and 2xn minus 1. If I want to trick you, I can do xn plus 3xn minus 4. Then how?
That's not going to be like that.
Correct. So,
Can you show an example?
okay, hold on, please. Okay, so the gentleman asked a question. If I give you a different equation, how to solve this? Xn times 2, right? Give you yn. Agree so far? So this is 2xn. Can? Right? Yn is equals to 2 times xn. Can you see the figure? What about xn minus 3? So what do? I put a delay here. This is xn minus 1. Agree? Connected to nothing. Xn minus 2. Agree? So this is now xn minus 3. Agree or not? Yes? Multiply by 6, right? And then sum. Agree? 6. Can you see now? Can you see the difference in figure if I change the equation?
Can.
So if I want to draw that thing again, then you have a big table to draw. Can you see? So then you flow, right? And keep on flowing. Can you see?
Yeah.
It's not so simple for this case. Okay. All right. Okay, so you have 18 marks for question 1, A, B, and C. And now we have the last question, question 1D. Okay, and in question 1D, the question says x of t is equals to 2 sine 2000 pi t plus pi over 3. And then this is a 7-mark question. And it says sampled at fs equals to 8 kilohertz. Find xn. So this is 3 marks. And then find yn. So this is 4 marks. Okay, so you have to find xn first. So this is trivial when you get this. So what do? Well, this is x and t. This is x of n over fs, right? Agree? So from xn to xnt to xn. So what is fss? So this is 8,000 in the question given to us. So we replace t by nt. Okay, so we are trying to replace little t by nt. So you will get the question. I'll write here. 2 sine 2000 pi. The little t become n over fs. N over 8,000. That's all. Plus pi over 3. Once you have done that, you will see the answer which is x of n, which is 2 sine. 2000 divided by 8000 is 1/4 pi over 4n plus pi over 3. So that's it. This is 3 marks, right? Only 2 lines. Okay, this is 3 marks. But yn is more difficult. So yn, so if you do it this way, then you will be totally wrong. You will try to do h of n convolved with x of n. So although this is a correct equation, you cannot do this because first and foremost, you realize hn looks like a very, very long sequence of numbers. Where's my hn? Yeah, in fact, infinite. So hn is an infinite sequence of numbers. So I cannot do it this way. All right. So instead, what is the correct idea to do is yn is found in the Fourier domain. Okay. And then after that, I will extract. Okay. But I will just tell you how is it done first so that you guys have an inkling. Okay. So the key idea is this. Find h of e j omega equals to pi over 4. That's the key. Why pi over 4? So in the exam, you have no time to think, because you already can identify that my input signal have frequency pi over 4. So I need to find the frequency response of HEJ pi over 4. But you say, what is this? I've already found what is HZ, right, guys? What is HZ again? So in the first part of the question, I found HZ is equals to Z plus 2 over Z minus 0.1. What is Z again? Z is a complex number. What is this guy? This guy is a complex number. What is 1 EJ pi over 4? This is a complex number. Okay. So what is 1 EJ pi over 4? Actually, 1 EJ pi over 4 isn't. So if you all do not know, 1 EJ pi over 4. Pi over 4 is 1 angle pi over 4 in polar form. It is, I think, let me count. Okay, guys. So this is why I would like to use MATLAB. I will say the absolute value of 1 times exponential of j times pi divided by 4. Answer should be 0.707, right? 1? Absolute is 1. The real part, sorry. 0.707. Yes, correct. So if I'm not wrong, this is 0.707 plus j 0.707. So you see, I have a calculator that can do real part of an imaginary part of a. So this is correct. Okay. So I'm showing you that 1 EJ pi over 4 is this complex number, 0.707 plus j 0.707. All right. So if I let z is equals to this number, I'll get something very interesting here. So I substitute z is equals to, you can substitute 1 EJ pi over 4, or if you want to do 0.707 plus j 0.707, up to you. But of course, if your calculator is like mine, that I can plug in polar form and solve it, it's very nice. But your calculator, I guess, can only deal with in rectangle form. So if your calculator can only deal with rectangle form, then you must do 0.707 plus j 0.707 plus 2. Then this is the z. And you have 0.707 plus j 0.707 minus 0.1. So basically you're solving for h when z is equals to e j pi over 4. All right, let's find the answer. My answer, let me find for you, is 3 angle minus 0.6058. Okay, I'll show you what I get. Let me use the MATLAB to do it. All right, so I'm going to show you that if you have a calculator like mine, which is, so what I do, z is equals to 1 times exponential of j times pi over 4. right? So I let z is equals to this number. Then I go z plus 2 for the top divided by z minus 0.1 for the bottom. I get this guy. Is it 2.46 minus j? So you guys minus j 1.709. Then you say, why did I get this number? So let us call this capital H. And then absolute of capital H is the absolute value. So it's 3. The angle of H is minus 0.6058. So this is it. So this is the magnitude. And this is the phase. Okay. And this is in the rectangle form. We don't like it rectangle form. Right. Once we have the magnitude and the phase, so the answer will come out now. Remember, my x of n is equals to, what's my x of n? What did I get upstairs? 2 sine pi over 4n, and then plus pi over 3. Now, when I pump through my system, my output is, okay, here's the trick, guys. I'm only pumping one sinusoid at this frequency. I have calculated the frequency response. This is the frequency response at that frequency, pi over 4. I told you that the magnitude will be changed by 3. The phase will be changed by minus 0.6058. So what is my output? My output is equals to 2 multiplied by 3. Where is the 3 from? The 3 is the magnitude gain. The magnitude will be amplified by 3 times. The original input is 2. It's 2. Okay? Then I will still get the sine wave. I will still get it at this frequency and this original phase. But my phase now is delayed by 0.6058. So this is my answer for yn. So this is the 4 marks. Okay, so how to get this question up? The first part is really, really easy. From x of t to x of n is trivial. We have done it last week. From x of n to y of n is not so trivial. You have to recognize that we are asking in this question to find the frequency response. The frequency response is derived from h of z. This is h of z. But what to plug in the z? The z, the interesting part is the frequency of the signal. This is frequency at pi over 4. So we plug z equals to 1 ej pi over 4 into z. We work out this sum and it comes out a complex number. This rectangle form is useless to us. We will convert this complex number into a polar number. The absolute value and the phase. The absolute value will be multiplied by the original signal's amplitude. So it's 2 times 3 is 6. The phase will be inserted into the phase behind. This is minus, so the answer is minus. All right. Any questions, guys? Oh, did I pause recording? If I pause recording, then you didn't see the last part. I'm so sorry. Okay, I'll just show you the answers first. So in the final part of the question, the Q1D, the first part of the question is really, really easy. It are given you xt and the sampling frequency, you're asked to find xn. So it's only a 2-step, you get 3 marks. To find yn is more difficult. To find yn, you will think that you need to do hn convolved with xn, but you can't do that because hn is of infinite length, so you cannot write convolution. Instead, you use the frequency response, h of e calculated at this frequency. Why pi over 4? Is because the input is only one signal at one frequency, pi over 4. We substitute ej omega equals to pi over 4 to evaluate the frequency response. We get the frequency response through h of z by substituting z equals to this frequency, 1 ej pi over 4. Z equals 1 ej pi over 4 means all the z becomes 1 ej pi over 4. So all these complex numbers will divide by complex numbers. You get another complex number. You get this complex number, 2.46 minus j, 1.709. This rectangle form is not useful. You have to convert into polar form. Magnitude and phase. The magnitude shows that at this frequency, the gain will be times 3. The original signal is 2 sine something. It will become 2 times 3. It will become 6 sine something. The magnitude will be gained by 3. The phase, however, will be delayed by 0.6058. The original signal frequency plus the phase minus the new phase over here. All right, so now I'm going to show you my MATLAB code to do this. Here, I will generate my signal. I will plot my signal, and then I will start to generate my output Y. I use the MATLAB filter. You can use the Python filter, define B and A, and get the Y. All right, let's see. The green one is the sign 2, and it is phase shifted. Can you see the green point with the pluses? That is the sampled. The green line is the continuous version of the sampled signal. So I've just drawn for you. Okay, now the output is multiplied by 3. The blue one, ignore the first part. The blue guy hits number 6. So the green guy becomes the blue guy, the output. Then how do I see that it's phase shifted? It's delayed by minus 0 point something. So the peak is delayed. Okay. So it shifts, right? All right. So you can take a look at the code and see how I did it. Okay. So the code is only less than 40 lines long. All right. So you can see. Okay. Okay. All right. Then the last thing I want to show you is something called FV2. FV2 is MATLAB's a very, very powerful toolkit, which allow us to examine the frequency response and the impulse response. So this is the impulse response. I click this button for time 0, 1, 2.1, followed by 0.21, followed by 0.021. I mean, if it shows me 0.0021 and so on. So this, if I click this button, it shows me my magnitude response. Right click here, do magnitude at pi over 2, sorry, pi over 4, which is 0.25 pi, 0.25 pi, the gain is 3. Okay, so you see, as I increase my gain, as I increase my frequency, the gain becomes smaller and smaller. The signal becomes smaller and smaller until where I'm 0.9 pi, which is almost the same. The signal doesn't have what they call it, it's not becoming bigger. The lower the frequency is becoming bigger and bigger. So this is like a low pass filter. The low frequency get passed, the high frequency get attenuated. All right, the pole zero diagram here, if you type this, there's a 0 at -2 and a pole at 0.1. Real part is 0.1, imaginary is 1e minus 50 is basically 0. All right, so what I'm showing you the MATLAB is how to use the MATLAB to basically check your answers. So I use FV2. What is B? B is the coefficients of the numerator. A is the coefficients of the denominator of HC, and then that's it. I can then use MATLAB to check all my answers to see if I'm doing it correct. All right, I'm going to pause now. So that's it. So it took me 1 hour to do this, but in truth, you only have 30 minutes to do this, right? If I'm not explaining anything, if you know how to do it, you can do everything in 30 minutes, right? Okay, I'll pause recording.